Okay, lastly, we have their metamorphic rocks. Metamorphic literally means to change form from the Greek word metamorphosis. Okay, these rocks form when existing rocks like igneous or sedimentary are changed by heat or pressure or both inside the Earth's crust or also by chemical active fluid. Metamorphism mostly occurs in the following three situations. First, we have the regional metamorphism, we have contact metamorphism, and then dynamic metamorphism. When we say regional metamorphism, or that is called mountain building, great quantities of rocks are subjected to intense stresses and high temperatures associated with large-scale deformation. The end result is an extensive area of metamorphic rocks. Okay, so basically, when we say regional metamorphism, the main force that applies here is pressure or intense pressure. Next, we have their contact or thermal metamorphism. When rocks become in contact with or near a mass of magma, change is caused by higher temperature of the molten mineral or material. In effect, the surrounding rock is baked. An example of such product is marble. So, for contact metamorphism, unlike for regional metamorphism, the main force that are at play here is on heat. But then the heat is not strong enough such that it will melt now the existing rock. Okay, unlike for the formation of magma, the heat is high enough such that the rocks will melt into magma. But for metamorphic rocks or for contact metamorphism, the heat is just right, just to change the structure of the rock. And then we have their dynamic metamorphism. It occurs along faults because of gravity and too much heat. So basically, for dynamic metamorphism, it's now a balance between heat and then pressure. Examples we have here. We have there a magma chamber, which of course is a result of intense heat of these rocks. So these rocks are turned into fluid. Then we have here this one in orange, we have regional metamorphism. If you're going to look at the location of this one right here, of this deposit here, so it's under this bed of rocks on top. So basically, that is already subjected into intense pressure. So this now is undergoing metamorphism, or that this rock here is turning into metamorphic rocks. Okay. Then another example of the formation of metamorphic rock, we have their contact metamorphism. Or example, we have this this gray deposit. Okay. This is a basalt. And then as it goes deeper, no, and if that's subjected to pressure, this basalt rock turns into green stone. Okay, that is already classified as a metamorphic rock because it's simply a basalt, which is an igneous rock that is subjected to pressure. That's why it changed into a metamorphic rock, which is a green stone. Or another, a basalt may also turn into schist when that is subjected into heat and then pressure. Pressure coming from, of course, the weight of these rock deposits on top, and then heat coming from the magma chamber nearby. So from basalt, it was transformed into a schist. Or we have here other examples. We have lime mud or sedimentary rock, there, limestone, sedimentary rock, and then it's now a marble if that is subjected to heat and then pressure. Okay, so it's now a metamorphic rock. Or this ones right here, these deposits right here, are already metamorphic rock because they are subjected into heat and then pressure. All right, so there. Now, metamorphic rocks can be classified into either foliated or non-foliated metamorphic rocks. For foliated rocks, these are composed of minerals that are drawn out, flattened, and arranged in parallel layers or bands. The magma producing this rock is not able to reach the surface, such that they intrude into neighboring rocks. Examples of foliated rocks are the following, like we have slates, schists, phyllite, or gneiss. Okay, this one. We have here this foliated. It's subjected into forces. So basically, it's flattened. That's why we would usually see the arrangement of the minerals as they are. It seems like they are also flattened. Okay. And so example of foliated rock, you can see there the minerals that seem to be flattened also. Okay, foliated rocks. Or another example, from this outcrop of conglomerate, if that is now subjected to heat or pressure, then it will now turn into a metamorphic rock, which is this one, a metamorphosed conglomerate. So from that outcrop, like for example these ones, if that's subjected to heat and pressure, it will turn into a metamorphic rock. Alright, like that one, foliated metamorphic rock. Another example, we have gneiss, and so you can see there the lines or bands formed now from the crystals now. So this is an example of a metamorphic rock, foliated metamorphic rock. And we have there schistose. That's not a lasagna, and so that is still a metamorphic rock, but you can see there the arrangement also of the crystals, like they are, it seems like they are flattened. Okay, and then we have there garnet mica schist. You can see that although it's not that visible, but in a microscopic scale, we would see the arrangement of the minerals as if they are foliated. And then, of course, non-foliated rocks. These are types of minerals that are not arranged in parallel layers or bands. And so there's no specific arrangement for these metamorphic rocks. Marbles, quartzites, serpentine, anthracite, etc. These are examples of non-foliated rocks. Like example, we have this marble. And more examples of non-foliated metamorphic rock. Although for gneiss, that is an example of a foliated metamorphic rock. Okay, so there you have I have the different types of rocks. We have igneous rocks, sedimentary rocks, and then metamorphic rock. And so I hope from this discussion, your knowledge on these types of rocks has been expanded, no? And like for just saying, igneous rocks are coming from magma, and so we were able to identify the different types or the different classifications of igneous rocks, sedimentary rocks, and then at the same time, we have their metamorphic rock. Okay, that is for minerals and rocks.